All right, let's dive into how the GitLab CI Runner device cloud for embedded development works. We're going to take a look at sort of a structure diagram here to understand how it works. Then we'll dive right into some hands-on with actually configuring one. We want to take embedded development and do that right inside of GitLab CI. We want to access some sort of embedded hardware setup. Typically, this is done in a manual way by attaching this hardware directly to a developer's workstation and allowing them to have some sort of interfacing to that so they can flash it, run tests on it, get feedback from it, attach a debugger. We want to get this into GitLab so that we can leverage it inside of GitLab. To replace that sort of workstation capability, we're going to add a runner gateway. So basically, some sort of device that can run GitLab Runner and interface with the device. Now, I've heard of some worst case scenarios where organizations have to use a full-on Windows desktop and interface it with the hardware and run GitLab Runner on there. If that's what you need to do, that'll work fine. I'm going to show you how to do it with a Raspberry Pi, which you might consider using if it's at all possible for your particular setup. When we go through this, we're going to want to put these Raspberry Pis with each of the embedded setups. And so when we do that, we end up with a lot of these. Now, if we don't make this into device cloud, well, then every developer would be able to use it in GitLab CI, but they'd be using the one at their desk. So they wouldn't be able to run multiple builds, and they wouldn't be able to take advantage of hardware that might be spread all over the world. And if it's expensive hardware, it'd be nice to be able to use that whenever other organizations aren't using it, to have it physically at their location. So we want to create a device cloud that then allows allocation and deallocation of these units virtually. This is actually leveraging your own hardware on-prem in your private organization. So what we're going to do is something fairly simple in order to get this to happen. We're going to take each of these devices and we're going to give them a CI/CD variable that indicates whether or not they're currently allocated or not. We want to do it in a dedicated project so that that project can be tracking a device cloud no matter what projects are actually using it at the time. It also helps us with security because we need a fairly high level of permissions in GitLab in order to manipulate CI/CD variables, so we can indeed keep that security concern isolated. Then on the GitLab side, we don't really want people writing and handcrafting code for this. And then if you have updates to the code, you got 50 projects that all have it spread out throughout the different projects. So we want to use a GitLab CI component. So this can be managed shared code that the projects that need it just simply depend upon. And so GitLab CI/CD components are a new capability in GitLab, and they are actually managed dependencies. So you actually depend on the component and use the code of whatever version you point to that is stored somewhere else. And so this lets a centralized team maintain the code so that they can keep it debugged for all scenarios. Now, this component also hides the actual code that does the work. So the CI YAML that someone has to deal with in order to work with this becomes very simple. Within this CI project, we're going to need to be able to locate the project that holds our CI data for this particular pool. And we're also going to need a token to be able to read and write those CI/CD variables. Then within this particular project, we're going to need the actual code that does the embedded build. And I've decided to separate this code into a separate file. It does a couple of things for us. One is in a very simple scenario where you only have one pipeline, you can simply create the file, it'll be auto-detected and used as the pipeline that runs on the embedded device. The component can be customized. So if you have multiple hardware rigs and multiple pipelines, you can start taking more control by adding more variables to have more parameters and potentially adding more CI/CD small jobs in order to expand it. When you first look at this, keep in mind that it's designed to do something really useful by default with what I call least configuration. But that doesn't mean it's not capable of more advanced configuration. So you really want to read through the help that comes with the component in order to understand all that it's capable of before you start to build on top of it. This works pretty well for a single project pointing at a single pool. But it's also possible by adding some upbound structures here to add more sharing. So if you have an upbound parent group to this particular project, and then we register our runners in there, well, now we can have a whole hierarchy of projects that can leverage that runner pool. We could technically have multiple runner pools in the same way for different hardware. One thing that we might be able to do is then flow down the CI/CD variables for configuring the component. Now, this will depend on whether most of the projects in the hierarchy default to a certain bit of hardware. So you could set it at that level. Say 90% of the projects use one hardware setup, but then other projects need either just one additional setup or a completely different setup. So you could default those variables to flow through the whole hierarchy and then override them in individual projects to force it to use a different hardware setup or to have two hardware setups in the same pipeline. So all of that's possible. I've prototyped this. It's working. It does require that everyone who's accessing the tagged runners that are in here uses the component and points it to the right stuff. So if someone just uses a runner tag and routes something to a runner, then it could very well clash with something that's properly using the orchestration capability. I was about to write a big long set of instructions on how to set this up after the prototyping. However, that would really be a pain in the butt. And there was also a lot of optimizations if I automated this. So it also includes a runner provisioning script that you run on the runner gateway. And when you do that, it's going to automatically create a runner. Now, it creates the runner token as well. So you're going to give it a group access token, and then it's going to create the runner token and register with the runner token. This allows us to have control over the tag, and we need a unique tag for every one of these runners so that we can allocate them exclusively. It then adds a variable to this pool with the right value in it, and that essentially provisions the runner into the pool. So now the runner can be used as soon as that particular step happens. This automation also does some other handy things, like if you make the overall setup an idea, there's a lot of flexibility in it as well for overriding certain things with different parameters as you go through. But the basic idea is that this component, when it can use CI variables to allocate runner tags and then schedule a child pipeline with that runner tag, we get an exclusive allocation of the device, and then we get a pipeline that sticks to that exact device the entire time it's processing. Now, there's other ways that people have tried to do this, but sometimes those ways only allow you to use a shell runner. And this particular solution works with both shell runners and container runners because we can get exclusive access. And then with the container runner, we just make sure we can only run one container on that particular runner. And the reason is we only want, we basically want a single threaded pipeline with our jobs going in order on the runner. So we don't want more than one container. But using container runners gives us some benefits such as better cleanup and the ability to isolate our runtimes and not have to manage monolithic runner images and also not have to manage basically a whole machine image. So essentially, if you have a whole lot of runtimes and you make this runner gateway a shell runner, well, now you've got to manage the image for that shell runner so it has all the runtimes you want. Where with container runners, of course, we bring our runtime set up for each job and away we go. So it adds a lot of flexibility to be able to use this with the Docker runner. All right, let's dive into some code.